Alright, the first question, the amplitude, right? You can go to the equation itself. It's f of x equal to minus 2 cos x. The coefficient of cos x is negative 2. Our amplitude is a positive value. So you take the positive of that negative 2. So the answer is going to be a 2. Okay? Amplitude is a 2. And let me just write it. Just move it. The amplitude is a 2. Okay, so let me write here. Amplitude is equal to 2. Then the next question now, it says, write down the minimum value of f of x plus 3. Now, what this means, by f of x plus 3, we are saying it's a new graph. Now, it's a new graph. And that new graph, you get it by shifting f of x by 3 units upwards. That's what it means. Okay? Because you need to know what this means. Your f of x is minus 2 cos x. Okay? So where there is f of x there, you replace that f of x by minus 2 cos x, you get a new graph. Okay? If I want, I can call it h of x, because later I have got g of x. So that new graph is going to be, I'll just have to replace the f of x by minus 2 cos x. Then I'll put plus 3. So what that means is this graph that you are seeing here is going to be moved 3 units up. So the maximum turning point is going to end up to what? You move a point which is at y equal to 2, it ends up being at y equal to what? 5. If you move a point which is at y equal to minus 2 by 3 units up, it ends up being at what? It will end up being at y equal to 1. So your answer is going to be positive 1. That's where the minimum value of the graph is going to be. So your answer here, well, your answer is going to be minimum value is going to be equal to 1. Are you following? Yeah, because if you didn't understand what I said yesterday, that's why I'm doing this lesson, so that I can clarify some issues that you might have been wondering, what was it talking about? Okay? So, you need to know that because of function notation, if you are given an equation, you can manipulate that equation into any question. It's not very difficult, right? And I can run them. And then you're supposed to sketch now this graph. You're supposed to sketch g of x equal to sine x plus 1. Now, g of x equal to sine x plus 1 means we are moving to the basic graph of sine, which is y equal to sine x by 1 unit up. Okay? So if you do that, you get the two graphs that you have will end up being these two. Remember, this one here is f of x. Remember that. And the top one, which is in black, that will be g of x equal to sine x plus 1. So you can check if you sketch the graph, that's what you're supposed to get. So this is minus 2 cos x. Okay? So these are the two graphs now on the same system of axes. Right? Then from these two graphs, you now need to answer those two questions. The first question now says, use the graphs to determine the following: the value of f 180 degrees minus g 180 degrees. All right, here we have got what's called function notation. Now, by f 180 degrees, it means where there is x here, put 180 degrees there. Where there is x there, put 180 degrees, but that's what this means. So where there is x in the original equations of the graph, Put what? 180 there. So this question you can do a calculation, right? You can do a calculation or you can go to the graph. There are two ways of getting the solution. If you can figure it out without a calculation, that's fine. If you can't, it is a problem for most learners. You have to do a calculation. I would suggest that you know, or at least you know how to get the answer by a calculation. So let's start by getting it by a calculation. If you were to do a calculation, right, f 180 degrees minus g 180 degrees is going to be equal to, where there is x there, I'm going to put 180 degrees. So we end up having minus 2 cos 180 degrees minus, where there is x there, I'll put 180 degrees. So it will become sine 180 degrees plus 1. Then you can use your calculator. What is cos 180? So what? Before the minus 2, what is cos 180 degrees? It will be negative 1, right? Then minus 2 times negative 1 will give you a what? A 2. Okay, you too. You need to pay attention now. Cos 180 degrees is equal to negative 1. Negative 1 times negative 2 give you a positive 2. Then sine 180 degrees is 0. Yes?
Why did you do it differently? You took the answer from there and then times it by 2.
Okay, remember, I'm not using a calculator, but you are using a calculator. So your calculator will give you the answers.
So we can put it in before like minus 2 cos.
Yeah, okay. Okay, China, remember, you are using a calculator, right? Your calculator, if you put minus 2 cos, it will give you the answer straight away. But in my case, I'm not using a calculator. So before I get my answer, I need to know what is cos 180 degrees. Okay, because the 180 degrees is a special angle. It's equal to negative 1. That negative 1. So that negative 1 times minus 2 will give me what? A 2. But if you are using a calculator, you get 2 straight away. Okay? Then here, sine 180 degrees. I need to know what is sine 180 degrees before I get the sum of sine 180 and positive 1. Sine 180 is a 0 degrees. So it's 0 rather. 0 plus 1 will give you what? 1. So the final answer will be, so it will be a 1. Are you following? Yeah. Please bear with me. I'm not using a calculator, so sometimes the way that I might say it, I'm saying it from my perspective of not using a what? A calculator. Right? So the answer there is going to be a 1. So here we just say this is equal to what? 1. If you can do that mentally, you'll get your full 2 marks. Okay? If you can do it mentally, then you can get your full marks. But the best way of doing it, without any doubt, without making unnecessary silly mistakes, is to do a what? A calculation. You never go wrong if you do it that way. Right? Then you can also use the graph. Right? But if you want to use the graph now, you have to go to where 180 degrees is. Your 180 degrees is here. Do you agree with me that where x is 180 degrees, the graph of cos is above the graph of sine? Okay? What that means is the graph of f, its y value is greater than the y value for the graph of sine. Because the cos graph is above. Okay? So, the value of y here is a what? It's a 2. That's the 2 that you get from the calculator. The 2 that you get by calculation is there on the graph, which is this one here. Right? Then, when x is 180 degrees for the graph of sine, the value of y is a what? It's a 1. Then you do a subtraction. Okay? So 2 minus 1 will give you what? 1. So this question you can do it using the graphs, or if you can't, you use this expression here together with your knowledge of the two equations, right? In the use of the calculator, then you get the answer. So both ways can work, but most learners won't be able to see it on the graph. Most learners won't be able to see it on the graph. That's why I had to show you this as well. Okay? So that in future, if you see a question, you won't say, I've never seen this. All right? Any questions? You following? Right. Now the other thing before I carry on to the next question. When you have got two graphs like this, right? If you pick any interval, if one of the two graphs is above the other, it means its y value are greater. Okay? If the graphs intersect here, like at this point and at that point there, it means the y values are equal at that point. Okay? The two graphs will be equivalent to each other. At this point here, in function notation, we say f of x is equal to g of x at those 2 points of intersection. The graphs are equal at those 2 points of intersection. All right? I can ask you many questions on these two graphs. Right? I can ask you many questions, but I don't have time. Right? Let's do 6.4.2. 6.4.2. Let's go. Right, now the next question. Can you try to do it on your own? Huh? Okay, let me imagine. Okay, just right. The y value for the cos graph times the y value for the sine graph are both positive. Their product must be a positive product. Or, so what that means is both y values must be positive, that's the first case, or both must be negative. All right? Now, let's go to quadrants now. If you remember last step, right, I told you about the concept of quadrants. The first quadrant, second quadrant, third, then fourth quadrant. All right? When we draw the graph, okay, we drew those two graphs in which quadrant? It's the first and the what? And the fourth. Right? Now, do you agree that in the first quadrant, the y values are positive? Do you agree with me then? Yeah, which means to get this answer here, you might have to look at the y values for both graphs such that they are in the what? First, such that the graphs are in the first quadrant. Right? Okay? In the fourth quadrant, y is negative. Now, these are basic concepts that you need to know when it comes to a Cartesian plane. First quadrant, both x and y are positive. Fourth quadrant, x is positive, but y is negative. Right? Which means if the graph is in the fourth quadrant, those graphs, if they are in the fourth quadrant in the same interval, it means you could get a solution there. But if one is in the fourth quadrant, but the other one is in the first quadrant within the same interval, that's not a solution. Okay? Both must be must fall in the same quadrant. 1, 2, it must be the same what? Interval. So let's start analyzing now from the beginning. The graph of G is positive up to the point of intersection, right? The graph of F, it starts as negative, negative, negative until we get to this point where where the y value becomes 0, because that's the x-axis. Along the x-axis, y is 0. Okay, along the x-axis, y is 0. So y is 0 now, which means f of x is 0 here. right? Then from here up to there, g of x is positive. It's now equal to positive 2 here. But y here is now what? 0. Right? Then suddenly the graph of g starts to become positive. It's now in the first quadrant. And the graph of g is also still in the first quadrant. Which means our first interval is going to start from what? From there. But we have to exclude the 90 degrees because we don't have an equal sign here. Okay? We don't have an equal sign. If there was an equal sign here, then we have to include that 90 degrees, but we can't include it here. Right? Then both of them are positive. They are in the first quadrant until we get to what? To 270. At x equal to 270, both graphs, that is their y values, are equal to 0. Here. So f of x is 0, g of x is 0. That's why f of x is equal to g of x at this point. Okay? Then let's move. So our answer is going to be from 90 to 270. Then let's carry on. Now suddenly the graph of cos is now in the fourth quadrant, but the graph of sine is in the first quadrant. We don't want that because they are supposed to both be in the first quadrant in the same interval. So from 270 to 360, the sine graph is in the first quadrant, but the cos graph is in the fourth quadrant, so we don't want that interval. Unless if it was saying less than what? 0. That's when you take that as a solution. So we only have one answer here, and that answer is going to be 90 degrees less than x is less than 270 degrees. Right? I hope you are following. Because everything I'm saying now, next year, that knowledge will be required. In the trick, it will be required. Once you understand that, even we say when you see questions on graphs, for your first standardized test is going to include the graphs. And there may be questions on what I'm talking about now. Okay? I hope you're following the analysis that I'm doing. This is detailed analysis now. Right? I'm not just getting the answer from nowhere. Now, this question you cannot just get, you cannot do any calculation. You have to look at the graph. Okay, it's different from 6.4.1, where you can use both the graph and a calculation to get the answer. All right? Any question? So, for the first one, all right, for 6.5.1, right, our equation, right, remember we are starting with f of x. Remember f of x is equal to minus 2 cos x, right? This graph has got a maximum turning point. If you reflect it about the x-axis, the negative sign disappears, right? So you end up having h of x equal to 2 cos x. That's the reflection part. Then you now need to translate this by 3 units downward. So you are subtracting now 3 from it. Okay? That should not be very complicated to do. Okay? You reflect f of x about the x-axis. If there was a minus, like in this case, the negative 2 converts to positive 2. If there was a positive 2, it becomes a what? A minus 2. Are you following that? Then you move the graph downwards by 3 units. We know that a translation downwards is a negative. That's why I put the minus. Okay? Now, 6.5.2 now. You should be able to sketch this graph. What is the amplitude of 2 cos x?
2.
It's a 2. So if you move a point which is the maximum x, y equal to 2 by 3 units down, where do you get to? What is 2 minus 1? Sorry, minus 3. Minus 1. You shouldn't take long to figure that out. Because if you are at 2, then you move 3 steps down, you get to negative what? Negative 1. Because the maximum value of y equal to 2 cos x is at 2. What's the minimum? You are starting from minus 2. Okay? The minimum value of y equal to 2 cos x is negative 2. You move 3 steps down. Minus 2 minus 3 will give you what? Minus 5. So the maximum value moves from positive 2 to minus 1. The minimum value moves from minus 2 to minus 5. So your range to be y is an element. You have to include both the minimum and the maximum. If you write range, you start with the minimum. Okay, which one is greater, minus 1 and minus 5? Minus 1, so you start with minus 5, then minus 1. Okay, then you are done.